Hello, this is the second video or second chapter of implementing sounds into Unity using straightforward vanilla Unity tools. Last video we were talking about how to implement a sound and change its mix setting based on attenuation curves. So we created a sound for the little fire, and as the player is getting closer to the fire, we can hear the audio more obviously. When it's inside of the smaller sphere, we can hear it 100% of the time, like on 100% volume, and as the user gets outside of that sphere, we can hear the sound less and less and less and less until we're outside of the sphere where we cannot hear that at all. On this video, I want us to look at how to implement even more interactions into the sound. So as we looked beforehand, when we look at the audio source, we don't really get a lot. We get either to mute or not mute the sound, to spatialize or not to spatialize. Those are just checkboxes that we can either check or not check. And we have a few different settings here for maybe the volume and the pitch, the stereo panning, the spatial blend, and a little bit more attenuation curves for how the sound is going to be played if it's a 3D sound. So Unity doesn't give us a lot out of the box. That means that we need to understand how to edit and manipulate things by ourselves using code, and that's what we're going to be doing today. Usually when I do those lectures live, I pull up a YouTube video of a father that is asking his kids to give him a recipe for peanut butter jelly sandwich. And the kids are trying their best to write the best recipe they can think of, and then the father tries to implement that recipe and basically fails many different times. Since I'm now not doing a live lecture and I'm doing this on a YouTube channel, I can't really show you the other video, but just go ahead and look for it. It's this video, so it's a father trying to ask his child for a recipe, and the reason why I showed that video is because it shows perfectly how Unity, code, and you as the sound designer are working together. So in this metaphor, Unity is the father trying to implement what you told it to do. You are the child, the frustrated designer that is trying to get its code to work, and the code is actually a separate software. This is not Unity, but we're going to need some other tools in order to get the recipe to Unity. And that is the little piece of paper right here, and that's going to be today Visual Studio. There are a lot of different ways to write code. There is a lot of different IDEs that can enable you to write code. Today I'm going to be using Visual Studios, but Xcode is going to work as well, or Writer. There are probably others that I'm not familiar with, but that's the one that I'm going to be using today. So in order to run that scene, you will need some kind of a code editor installed on your computer. And as I said, today we're going to be looking at Visual Studio. For the sound that we're implementing today, that's going to be the sound for the little bird. And the bird is right here. I actually don't need that game view right now, so I'm just going to hide it over here above. I actually even don't need the asset store at all, so I can just go ahead and close that tab so it doesn't get in my way. So we're going to be looking at that little sparrow, and to get to that little sparrow, I'm just going to hit F and it's going to zoom on to that little bird. And that little bird, you can tell it has this box, this green box around this. This green box is actually a box collider. So I talked in the previous video about how you can kind of walk through that bird and nothing is stopping you. And that's because when you're adding a material or when you add a component into Unity, it doesn't really know that this component have physics and you can't go through this. You need to add a little bit more code to tell it, oh, by the way, that thing is collidable, or something can like go and touch it. So there are two ways of doing it. One of them is it's check for a collision, so it's checking if something is touching it. And the second one is we have right above here rigid body that says this thing have a mass to it. And it can be kinematic or not kinematic, or it can use gravity and then it would fall down. And those are all settings that you need to add on top of your little model in order to tell Unity, by the way, this is not just air or a cloud. This is something that can detect collision, and also sometimes we want to add code to like either make it fall over time and have gravity, or like move to the side when things are trying to touch it. Right now we're not going to do that. The only thing that we're going to do is just add a rigid body so things can so the editor knows that it's a physical object. And the second thing that we added is a box collider, and the box collider just let us check what happened when something is touching it. That's all we're gonna do for now. Don't worry about it right now, but it will make sense further along in this tutorial. So we're looking at that little sparrow, and we can see that it has an LOD, which is a level of details, and it has an animator that is making sure that this bird is animated, and it has my rigid body and a box collider. As we said in the last video, the first thing we need to do to enable it to play a sound is to add a component, and that component is going to be an audio source. So it's already written down for me here, but if you see the view and it looks something like this, all you need to do is either go into audio and see the audio source, or you can just type it in, audio source. There we go. And we just added an audio source. And the first thing that I'm going to do is, as I did in the last video, is take that number of 500 and put it on about 10, something like this, so I can actually see the attenuation here. And then I'm just going to take that number and take it all the way down to 0. So outside of that little sphere, I'm not going to be able to hear anything. And right now my clip is empty, so I'm just going to go to the bird clip. And I have a little clip here that sounds something like this. And I'm gonna, sorry, I know that you didn't see this. It's because my video is right on where that sound is playing, so sorry you didn't see this, but in your editor you're gonna see like a little box. There it is. So I brought it all the way up, but for you it's gonna be down exactly where my camera is, and you're gonna be able to see the sound. So let's go back to our little sparrow. If I press on the object itself, it's gonna show me in the inspector everything that it has. And right now in the audio clip it says nothing, so I'm just gonna go to my clip and drag it in. Play on awake is already checked. Let's just check looping so we can actually hear and test that that sound is working in context. So let's just hit play and see how that sounds like. Oh gosh, this is loud. So let's stop this. What we forgot to do is move that slider from 2D all the way up to 3D. Let's try that one more time. So now we can't hear anything until we get closer to that bird. Let's see this actually in the scene view as well, like this. So let's move towards it. And right about here, I should start hearing the sound. There it is. So now that we got a sound playing, what I want to do is kind of close that audio source and look at how to get a script to change or manipulate how we're hearing the sound. So we have a little bit more control than what Unity is giving us out of the box. So I'm going to press add a component, and this time I'm going to look for a C# script. So if I scroll all the way to the bottom, I'm going to see new script. I'm going to press on that new script. It says new behavior script. Let's name it something a little bit better so we actually know what we're working with. So let's call it bird sound. Bird sound script. Actually, let's just make this one a smaller letter. Bird sound script. It doesn't actually matter how you name it. You can name it whatever you like on your end. And we're just going to create an add. So in order to manipulate the sound a little bit better, what I want to do is control it using a script. So for that, the first thing that I'm going to do is I'm going to close that audio source. It's still there, but now I want to add another component, and that component is going to be a script that we create together. For that, the first thing that I'm going to do is add a component. And my component, if I scroll all the way to the bottom, it's going to be new script. And this new script needs a name, so we're just going to call it, bird chirping sound. It doesn't actually matter how you name it. You can name it whatever you want on your end, but it's going to be harder if you change the name in the future. So just pick a name and go with this. I'm going to click create and add, and we're seeing that script just added here in my folder, because basically this is another ingredient that we're adding to our fridge that from now on we can use for other things. For right now, we're using it only on one component, which is this one. So after this, I'm going to press on the three dots right here. And I know you can't see this, but on the bottom, it says add edit script. So press that. And then it's going to open Visual Studio. And while Visual Studio is opening, that's going to be our little recipe to show Unity what needs to be done. And Unity can read that type of language and can actually perform actions based on what we're writing right here. Now, the biggest problem is that Unity doesn't speak English. It speaks a different language, and that language is called C#. And it might be very confusing if you don't speak C#, and most humans don't speak C# because it's not a language that we use for communication, but it is a language that we're going to be using now in order to tell Unity what we wanted to do. So right off the bat, when I look at that script, it comes, wait a second, just make it a little bit bigger. It already comes with some things built in. So it's not completely empty, and it comes with, let's see, we have using system collections generic. This is just telling me what kind of components are going into my recipe. And then it also says using Unity engine. So basically all of those are references to packages or some kind of code that is already embedded within our editor. So what it tries to tell us is these are the systems that are going to be using, these are the type of languages that I do understand. Well, not languages, but more of like, these are the, I don't know, components that I can be, I'm familiar with the terms of that specific collection. The next thing that we see is a public class, which is a type of a script, the name of our script. And this is why I said this is important to keep that name similar to, this name. So basically, if this name doesn't match the name that we have here, then you're going to have errors. Let's just try this. Instead of sound, I'm going to write the word audio, and I'm just going to hit save. And right now, when I look at my little sparrow, it says that something is missing because it's looking for a script that is called bird chirping sound, and I just don't have a script that matches this because there's some kind of a problem with the script. And the problem in the script is that the name here does not match the name here. So just make sure that those match, all three of them. So 1, 2, and 3 match to the same one, and you will run into issues if they don't match. So just keep that in mind. The other thing that we're seeing is we have those things in green that are started with those 2 slashes. We have this here and we have this here. Those are comments. So anything that you want to comment on your code is going to be marked in green. And in order to do that, all we need to do is do like 2 slashes, and then I can write whatever I want. And it won't read it. And Unity won't read it. And Unity doesn't read it because it knows to ignore comments. Those are mainly for the developer or the designer. It's not really important for Unity. Many times what developers would do if they're not sure if the code is working, they're going to go to some of the lines and they're going to comment them out, meaning please ignore them in order for me to test other things that are happening because those lines might have problems in them. So when you're writing your comments, or if you're not sure about something and you want to write a comment, that's the way to do this with those 2 slashes. Unity also comes with 2 functions in it. So it has void start and it has void update, followed by the curly brackets, these ones. And all of this is encapsulated within bigger curly brackets. And those curly brackets tells us where the code starts and when the code ends, and it's all encapsulated into one place. And the same with the different functions that we can perform in the game. So we have void start. Void, by the way, just means do something. Just treat it this way. Do something on start. And usually when we have an action, we'll also add those brackets around. Right now they're empty because they're not waiting for anything. So do something on start. And anything that we want to happen on start, like on the first frame, we're going to put it here. Then we have another one. Update is called once per frame. So do something update means do something every frame. There are a lot of frames happening and the changes are going to be very rapid here. So let's see what we can do. In order to write a recipe, if you ever written a recipe in your life, the first thing that we need to do is specify what ingredients we're going to be using for that recipe. So for us, the ingredients are going to be the audio source, meaning the thing that plays the sound, and maybe other components in the sounds. But let's start with just an audio source. So in order to tell it that we need an audio source, we need it inside of the outside brackets. We're just going to create some empty space here, right here. And we're just going to write audio source. And now we need to give it some kind of a name. So we know from now on when we refer to that the audio source, it's going to be called that. So for that, what we're going to do is we're going to invent a name that we can remember. So I'm going to call it my audio source. And then I need to put a semicolon in the end. And you'll notice that the way that I wrote it down is the first word is not capitalized, the second one is, and the third one is, and so on. That is called camel casing because it kind of looks like a camel, and this is usually the practice when you're writing scripts. So we have an audio source and it's called my audio source. Now, in order to see that in the editor, I'm just going to make it public. And when I write the word public before things, it means that it's going to appear in the inspector. So I'm just going to hit save now, and let's just see what happens in the inspector. Okay, now we have a script. We have a reference to that script itself here. And then we have my audio source, and check now, and you'll see that this is capitalized. So when you're writing in camel case, it will actually come out regular when you're looking at it in the inspector. And right now it says none, so it's looking for a reference for an audio source. You need to tell it which audio source it's going to be. So let's just take that audio source here, and we're just going to drag it to the bottom to here. So, whoop. And now we have a reference of our audio source. If we look at the code again, what do we actually want the code to do? So let's say we want the code to make the audio play. So let's look at our little audio source, and we can see that right now play on awake is checked. But maybe we want to uncheck this and see how we can call that using code. So we're going to go here. And right now I have a reference for a type of an audio source, and we called it my audio source. So what I can do is say, hey, now that you grab that reference, so take my audio source. If I put a dot after things in Unity, it means inside of, or like it's a smaller component inside of something else. So my audio source dot, and then we're just going to say play. We have to add those outside brackets, the round brackets, I'm not sure how they're called, and semicolon after this. And I put those in because it's an action. It's say, like, do that thing. Just like void start is like do something on start. So right now we're saying play on start, right? We're calling this before the first frame update. So basically, even though it's not checked here, let's see if it's still gonna play. Oh, forgot to hit save on it. Let's hit play. Play on awake is off. And even though the play on awake is off, we can still hear the sound because we called it through code. So we can basically overwrite anything we want in here. So let's try to overwrite other things. Let's now try my audio source dot, I don't know, volume. And volume is not an action, it's a number, like it's a value. So instead of that, we're gonna say volume equals 0.5f. And then I need to put a semicolon in the end. The reason why I added an F here is because Unity have two types of numbers. It has float numbers, and float numbers are gonna be like 1.4 or 10.0, or it could be, I don't know, 0.5. We also have integers, and integers can only be numbers like 1, 5, 9, 100, and so on. So if we want a number with a fracture in it, we have to write float, and the way we represent that number is actually with Fs. So something like this. So even if it is a full number, like even if you go from 0 to 1, you would write 0 float and 1 float, something like this, or even better, 1.0f, something like this. And again, those two are commented, so they're not going to be compiled in my code. So I can always write little comments here. Ooh, I can also close them. Oh, that's cool. I didn't know that. So, my audio source, please play, and also put the volume on 0.5 float. So right now the volume is set to what? To 1. So we should see it moving by itself to 0.5. And we can see on the side that the volume indeed changed to 0.5. What else can we do now? Let's change, I don't know, the pitch. My audio source dot pitch is going to be equal to, I don't know, I want 2.3 float. I'm going to save. Gonna hit play. Look at our little sparrow. Pass by our little fire from the last chapter. Oh, that's painful. But like, okay, so I can change things through code, but it's kind of tedious to every time go to the code and like, let's say I don't want it on 2.3 because that was kind of ear piercing. I want it like 2.0, or I want it on 1.4. So that's a lot of adjusting within the code. So instead of doing that, what I can do is change all of this into something else. Let's see how we can make this a little bit more dynamic. So I'm gonna go up to the components that I'm using, and right now I'm only using an audio source called my audio source, but under this I can declare other things. So I'm going to declare a public so we can see it in the inspector. Public float, which is just a number, it's just a value, and we're going to call it my volume. And by default, let's put it on 0.5 float. And I'm also going to create another one called public float my pitch. And let's say by default it will be 1. But again, I'm just going to do 1.0 float and then a semicolon. Let's look at it now. Let's just close our audio source because we don't need to see it right now. And if we look just at our little script, because now we have this reference to the audio source here, now I have my volume and my pitch exposed here. And here's an interesting part. If I just take my mouse, I can always write a number here, but if I just move my mouse all the way to the name of that float, then I actually have those two little arrows, and I can just slide up and down on different integers and adjust it here. Sorry, those are not integers, those are floats. So let's see if it worked. My volume is now 0.34 and my pitch is 0.77. Did it actually do it? Let's see. So it didn't update this, and let's try this one more time. Actually, I know why it didn't register it. The reason why, it's because I didn't connect them in the code. So let's do that right now. So now I have my volume and I have my pitch. So here, instead of just one volume, I'm going to change that to my volume. And I'm going to change that one to my pitch. Now let's try it one more time. So here we're going to put on my volume, we're going to put, it shouldn't go to negative values, so we should fix that, but in a sec. I'm going to do this, and the pitch is going to be, I don't know, like 1.16. And let's hear it now. Let's look at our audio source, and in fact, it changed to the values that I chose. Now, if I keep changing it now, nothing is going to happen because it only updated it once. It updated it when we started the game, so right now it's just going to stay on that value. But we now have the ability to change this using our script and not looking at our audio source at all. And that way, that technique that I just showed, you can basically control everything with this. So let's see even more things that we can do with it. If I go back to my script, instead of void start, how about we take that, I don't know, like let's say the pitch, and I'm just gonna Control X, and instead of putting it on start, so it takes a value on start, we're gonna take it to update and put it right here. And instead of my pitch, we're just gonna give it a random range. So for that, I'm gonna write random dot range, random range, and I'm gonna give it a value of, I don't know, 0.3 float, and 1. So now the pitch is going to adjust itself every time a frame is called. So think about how many times a frame is called. This is going to change randomly. Let's hear that. If I look at my audio source, I can tell that this is just like jumping around between those values and picking them randomly. Okay, and how would I declare something like this? So instead of having the random range just two specific numbers, maybe we can declare it on the start. So instead of my pitch, we can say my minimum pitch, my min pitch, and then I'm going to take the same line and I'm going to put a maximum pitch. So my maximum pitch, and then this will default to, let's say 1, and the maximum one is going to default to 3 for now. And again, in this range, instead of that specific number, we're going to do my min pitch, my max pitch. So again, if I close and collapse this one, now I can see that I have my minimum pitch, my maximum pitch, and I can now change them like that. And let's see this again. And because this one is updating every frame, we can actually now go and change the range to make it move in a different place. So I know you just didn't see what I was doing, but I'm gonna close this, and I was adjusting those numbers and seeing how the values here change. So basically, you can do that on play. It's not going to save anything, and it's going to go back to the default settings that you set because it doesn't save any changes that happen on play. But at least now it's available for you here, and you can always change this. And we did have a problem with the volume because the volume right now can just go to minus values, and we don't really have those values in Unity. We only have volume that is between 0 and 1. So we want to kind of like clip that so it can only go between values of 0 to 1 because those are the values that Unity accept. So for that, I'm going to go back here, and where I declared my volume right before that, I'm just going to create a range, and my range is going to be between 0 float and 1 float. And I'm going to save this. And let's see what happens now. I'm going to go back to the editor and check this out. Instead of that reference to my audio source here, I can actually tell Unity itself to just do the work for me and find that reference without me needing to like drag that down and make sure that it's the right reference. Let's do that. So instead of declaring it here, I can always declare that here, but instead of a public audio source, I can hide it. And instead of that, instead of me dragging it down, what I'm going to do is I'm going to tell Unity on start, what I want you to do is get component. The component type is audio source. And because it's an action, I'm just going to add those brackets in the end and close it. And please get the component that you call audio source. And from now on, also, my audio source is from now on that audio source that you fetched. So when I'm telling you my audio source, what I actually mean is get the component, get component audio source. Let's see that. Awesome, we got that to work. The last thing I want to do is actually open our own function. So until now, we looked at two functions that exist within Unity. One of them is the void start, meaning do something before the first frame is called. And the other one is void update, meaning do something every frame call. But now I want us to open a completely new one. And luckily, Unity comes with a lot of different functions already built in. They just don't give it to you on an empty script. So we need to call them ourselves. For that one, I want us to do something, not on start and not on the frame, but I want to do something. Remember in the beginning of that video, we talked about collision and how things can actually check and detect when something is colliding them. We're going to use that collision box to say when something is hitting me, when I'm being triggered by an object, do something. How am I going to do that? I'm going to create new lines on the bottom. If I want, I can write a comment for myself. Comment. If you need to, write something. But we can actually use that to say call on collision trigger. Now this time there are two different functions that we can use. One of them is on collision enter, and the one that we're going to be using is on trigger enter. And in order to use on trigger enter, when you're looking at your box collider here, it says is trigger, and it needs to be turned on so it can actually detect when something is triggering it. So we're gonna write void, which is our do something. And now we're gonna write on trigger enter. And it already wrote part of it for me, but let me just explain to you what is happening here. Right now it says a private void, but private means that I'm not going to be able to access it using other scripts. So I'm just going to remove that word private because I don't need it to be private. I can make it public. So by default, functions are public unless I want to hide them, which is why private exists. On components, it's the opposite. It's going to be hidden until you add the word public to it. So there's two different methods happening here. One of them you have to expose things, and the other one you need to hide things. Now we do want that function to appear, so we're just going to say void on trigger enter, which is part of Unity's language, and Unity is aware of collisions and triggers because it's built in within the engine. So basically what you're telling Unity is, hey, you know that you have this concept of collision boxes? I want to use that, please. So just check whenever something is colliding you. So this script is not just any words. You do need to use that term on trigger enter. And then followed by, how do we know that it was triggered? We're checking for the collider, and we also need to give it a name, which is other. So inside of that long function, what do we want to happen? So maybe we can move that play. Instead of just playing in a loop all the time, we only wanted to make a sound when we interact with this. So we're just going to take that my audio source play, we're going to remove it from here, and we're going to add it over here. My volume is still set in the beginning. The randomized pitch is set here. And the only thing that was left for me to do is actually just remove the looping sound because we don't want it to loop. We want it to play only when we're colliding with the character. So right now we shouldn't be able to hear anything unless we're getting closer to that little bird, which is when it's going to make a sound. And the sound that it's going to make is the sound from the audio clip. All right, let's see it. No sound. Let's just touch the bird. And it didn't play a sound. That's interesting. Let's see what's wrong. I think I didn't save it. Let's try again. Even though that's weird, because I did remove it, so it should work. Oh, there it is. I, in fact, did not save the scene, which is why our script did not work beforehand. But here. And it's still kind of going crazy with the pitch. I kind of don't want that, so I'm just gonna use my own methods and comment out that line. So I'm just gonna go ahead and comment it out, and now Unity's gonna ignore that script, and we're just gonna get the regular pitch. Hopefully. Ah, that's so much better. So now we have our little fire, and we have our little bird. So I just triggered it twice because I got into this collision box above it twice. By the way, you can make the collision boxes bigger or smaller based on the object that you have. This is just my choice right now to put it like around this little bird. Well, that's the end of this video. There's going to be a part 3 where we're going to be looking at the radio, and even a part 4 where we're looking at spatialization and adding spatial audio to it. Stay tuned. I hope you like it. If you have any questions, please follow up either on the comment section or on the Sonic Sphere. The link is going to be in the description.